Hey guys, welcome to the worked answers for the 2019 Day 1 MCAT exam paper. Apologies for the fact that this video is longer than the 60 minutes you get in the exam, but I've done my best to explain things along the way and manage a sometimes laggy interface. Just be aware also at some points that the video freezes, but it's only for a few seconds, and the audio runs smoothly throughout so you can still keep up. With that said, let's get into it. Okay, question 1. What is the value of 2x to the power of 4 minus 3x plus 5 when x equals negative 2? Okay, so this is a pretty straightforward substitution question to get us kicked off. Let's first write out our equation, 2x to the power of 4 minus 3x plus 5, and it says x equals negative 2. So all we're going to do here is, wherever we see x, we're going to substitute in negative 2. So here and here. So we're going to say 2 minus 2, and that's to the power of 4, minus 3 times minus 2, plus 5. And simplifying this, you've got 2 minus 2 to the power of 4 is 16, because you've got minus 2, 1 minus 2, 2, minus 2 to the power of 4. Of course, no calculators in the MCAT. This is 2, this is 4, this is negative 8, and this is 16. So you've got 16 in brackets. Minus 3 times minus 2 is positive 6. And then plus 5. And simplifying this, you've got 2 times 16 is 32. Plus 6. Plus 5. And this gives you 43. And the correct solution will give you the achieved, guys. Okay, let's keep going. Okay, question 1b. Solve the equation 10x squared minus 27x minus 9 equals to 0. Okay, so it's a quadratic. We're solving for x. When the a value is greater than 1, and what I mean by that is a quadratic is in the form ax squared plus bx plus c. When a is greater than 1, there's a few different ways to solve it, to solve the quadratic. And you might have your own way. I tend to use the way I'm going to show you. First thing I do is a times c, so basically 10 times negative 9. And this gives us negative 90. And so we're looking for two numbers that multiply to negative 90 and add to minus 27. And this is positive 3 and minus 30. So now we've got 10x squared. So now we split the b term, 10x squared minus 30x plus 3x minus 9. And this equals to 0. And now we split the whole quadratic. We put a line down the middle and we factorize the left side. You've got 10x. And then inside the brackets, x minus 3. And plus 3 on the right hand side. And the bracket is x minus 3. And you know you're on the right track when the two brackets are the same. and now 10x plus 3 is its own bracket. And of course you've got x minus 3 equals 0. And now we've got two sets of brackets that equal to 0. You've got 10x plus 3 equals to 0. And therefore x equals minus 3 over 10. And for our second solution, x minus 3 equals 0, meaning x equals 3. Okay. Correct solutions get you the merit here, guys. Obtaining the quadratic and going some way towards factorizing gets you the achieved, so let's say somewhere around here. Okay, let's keep going. So question 1c, find the values of x if 36 times 6 to the power of 2x plus 6 equals 6 to the power of x squared. Okay, this is a classic MCAT question, guys. Let's start by writing out the question as always. 2x plus 6 equals 6 to the power of x squared. And what we're going to do is look to write all of our numbers with the same base. And what I mean by that is you can see you've got 6 here, but this is a 36. And so we want to write 36 as base 6. And we can do that by saying 36 equals 6 to the power of 2. It's crucial, guys, to know your powers in MCAT. Powers up to 6, so 1, 2, 3, 4, 5, 6. Maybe even 7. So back to the question, we can say 6 squared now times 6 to the power of 2x plus 6 equals 6 to the power of x squared. And now we use our power rules with the same base. We're multiplying, so we can add the powers. We combine it into one power, so you've got 6. 2 plus 2x plus 6 gives us 6 to the power of 2x plus 8. And this equals 6 to the power of x squared. And now another power rule comes into play here. When you've got the same base and they equal each other, we can actually cancel out these bases, guys, because we can say that the powers also equal each other. So we've got 2x plus 8 equals x squared. And now you can see a quadratic starting to form. Let's put it in quadratic form. You've got x squared minus 2x minus 8. And okay, this is a pretty straightforward quadratic. Our two numbers we're looking for are positive 2 and minus 4. So x plus 2 and x minus 4 equals to 0, and therefore x equals to negative 2 and positive 4. And your correct solutions, guys, will get you the excellence here. Just checking. Yep. Correct solutions gives you the excellence. And actually, pretty straightforward excellence, guys. Once again, these are, same base questions. In this case, it was the 6 crops up in every MCAT. So you've got to be prepared, and often it's merit or excellence, and you can get that easy marks here, basically. Your merit, you solve your quadratic. So here, maybe it was incorrect working, but still you solve your own quadratic. And then your achieved would be writing in the same base. So even just up here gets you the achieved, guys. Okay. Okay, question 1D. The plan of a rectangular garden is shown in the diagram below. Okay. We've got some dimensions here, 8x plus 3, 6x plus 2, 2x minus 5x. And so you've got these, got to be aware, you've got flowers and garage and lawn, so three different sort of parts that make up this diagram here. And the question asks us, if the perimeter of the lawn is 290 meters, then find the value of x. Okay. Yes, and note the lawn does not include the shaded garage or flowers. So the first piece of information to understand is P, which equals, obviously perimeter is sum of sides, right? And that equals to 290. And we're trying to find x. So what we're going to do is form a equation or an expression for the area, for the perimeter of this lawn. Set it equal to 290, and we can solve for x from there. So what is the perimeter? Keeping in mind that the lawn does not include the shaded garage or flowers. So if you've got a highlighter in the test, this really helps you. Let's highlight exactly what we're looking at here. So not including the shaded garage or the flowers, it's this. This is the perimeter of the lawn. Okay. Now let's add in a few more measurements. Obviously, looking at this top side, that's not 8x plus 3, it's going to be 8x plus 3 minus 3x minus 2. Due to this measurement here, a minus 3x minus 2. This right hand side now, it's not 6x plus 2 because that's the whole measurement, including the flowers. And so this measurement will actually be 6x plus 2 minus this x down here, minus x. Okay, you've got 2x minus 5, that's included. You've got x. And the bottom part down here, again, we're using 8x plus 3, but that's not the measurement. It's 8x plus 3 minus 2x minus 5. And the left-hand side, you've got, again, 6x plus 2. And it's minus 2x plus 1, this measurement here. 2x plus 1. 3x minus 2 is included, and again 2x plus 1 rounds off our dimensions here. So we're going to add all of these terms up together. Let's write it out. What have we got? Just looking at the top, 8x plus 3 minus 3x minus 2. You've got 8x plus 3 minus 2x minus 2. And then the right hand side, it is 6x plus 2 minus x. So it's plus 6x plus 2 minus x. And now we start to look at the flower bed. 2x plus 5. 2x minus 5, sorry. Plus x. This bottom measurement, 8x plus 3 minus 2x minus 5. And of course that's in brackets. And we've got to come down the second line, adding 6x plus 2 minus 2x plus 1. It's a pretty long-winded process, but that's typical of these sorts of geometry MCAT questions. And then we've got plus 3x minus 2, and lastly plus 2x plus 1. Okay, now we're going to basically expand the brackets when necessary and collect like terms. So just conscious of space, we're going to okay, now let's go ahead and expand these brackets. So 8x plus 3, so it's minus 2x plus 2 plus 6x plus 2, and here we can, now let's keep going, 6x plus 2 minus x plus 2x minus 5 plus x plus 8x plus 3, and then minus 2x, we're looking here, minus 2x plus 5, now to the second row, plus 6x plus 2, and now expanding this bracket, minus 2x minus 1 plus 3x minus 2 plus 2x plus 1. Okay, and now we can now we go ahead and collect like terms. And what I mean by that is all of the terms with x in them. You've basically got terms with x and you've got single digits on their own. So just to help ourselves out, let's go ahead and highlight the terms with x. You've got this, you've got this. It's 2x plus x, 8x. Okay, and our terms with just single digits. Let's use red. It's plus 3, plus 2, plus 2, minus 5, plus 3, plus 5, plus 2, minus 1, minus 2, and positive 1. And now we can go ahead and add all these up. And you will find that 3x minus 2 okay, let's go ahead and do it. I have seen one mistake in here. This first bit of working, actually, this one here should be a 3x minus 2, making this one 3x minus 2. And hopefully, barring any other small mistakes, we'll go ahead and add these up. So if looking at the green, we've got 8 minus 3 is 5, plus 6 is 11, 10, 12, 13, 21, and 19, 25, 23, 26, and 28. And yep, just looking at the arcing schedule, that is correct, so 28x. And now just our terms with the single digits, you've got plus 3, plus 2 is 5, plus 2 is 7, minus 5 is 2, plus 3 is 5, plus 5 is 10, plus 2, 12, 11, 9, plus 1 is 10. Plus 10. And of course, going back to the context of the question, this perimeter is 290. So equals to 290. And now all we have to do, we've got our linear equation, we can solve for x. 28x equals to, let's move the 10 to the other side, equals 280. And this gives us x equals, divide by 28 on both sides, x equals 10. Okay, and believe it or not, guys, a fair amount of work, but x equals to 10 gets you the merit. No excellence here, but merit. Getting an expression for the for the perimeter gets you the achieved, so up here. Okay, let's keep going. So question 1D2, if L equals x squared plus x plus 1, find an expression for the area of the lawn in terms of L. Okay, now we get into area, and we're looking for area of the lawn. And of course, there's no straightforward way to do this. Indeed, there's multiple ways of doing it. You might go ahead and split these parts up and then do it in parts, or you might go sort of, downwards, so a series of rectangles. That's one way. I like to do it another way. So I'm going to say this. Apologies. I'm going to say this. We're looking for the area of the lawn. So area lawn in subscript equals the total area of that shape, including the flower bed and the shed. Is it a shed? Garage. Total minus, this is total minus area of the garage, so G, minus area of the flowers. Okay, so we've set up sort of an idea of what our area of the lawn is. It's the total area minus the garage and minus the flowers. And now all we need to do is express this in terms of the actual side length. So area of the lawn, that's what we're finding, equals area total area, so the whole shape, and just drawing an outline, it's like using the red, basically this whole shape, and it's a square or it's a rectangle, and so our dimensions base times height is 8x plus 3 and 6x minus 2. 6x plus 2, sorry. 8x plus 3 and 6x plus 2. So that's what we're going to say. Oh, apologies. So it'll start with 8x, 8x plus 3, and 6x plus 2. And then area of the garage, going back up. We're fortunate that the garage and flowers are both rectangles. So area of the garage, its dimensions are 2x plus 1 and 3x minus 2. So going back down, 2x plus 1 and 3x minus 2. And area of the flowers, one more, is 2x minus 5 and x for the length, for the width. 2x minus 5, and I'm just running out of room here, 2x minus 5 and x. Okay, and so we can expand these brackets now. So expanding this first quadratic, you've got 8x times 6x is 48x squared. 8x times 2 is 16. Apologies. 16 plus 18x gives you 34x. And then plus 6. And then we're going to keep our negative sign, and we're going to expand this bracket first of all. So 6x squared, and of course is inside the brackets. 6x squared minus 4x plus 3x gives you minus x and minus 2. And again, just maintaining our negative sign, 2x squared minus 5x. Okay, now let's expand these brackets left over. And of course, when I say expanding brackets, guys, it's a skill you've hopefully come across in your year leading up to the MCAT. So FOIL method is a common term: first, outer, inner, last. So minus, expanding now, you've got minus 6x. Minus 1 times minus x is positive x, and positive 2. Minus 2x, positive 5x. Okay, we collect like terms. Once again, you can highlight them if you want. Let's even do that. So we're going to add the x squareds. We're going to add the x's. And we're going to add just the single digits. So we've got 46. Apologies, yeah. This is 6x squared in here. And of course this is blue. 6x squared. So not 46, but rather 40x squared. 34 plus x is 35, plus 5 is 40x. And you've got 6 plus 2 equals 8. Okay, so we've got this quadratic expression for the area of the lawn. But looking at the question, it's asking, you've got this idea here, L equals x squared plus x plus 1. And, you can see there's some correlation because if you look at the coefficients of x squared and x, it's 1, right? And you've got 40x and 40. And so there's some similarities here. What we're going to do let's multiply L by 40 to get these A and B terms the same as our expression for the area of the lawn. So we can say 40L equals 40x squared plus 40x plus 40. And now they are similar. But looking at the C term of our quadratics now, you've got 40 here and 8 here. So again, there's some difference. We can say, and this is just understanding sort of simple manipulation of these like polynomials, right? We're finding an expression for the area of the lawn in terms of L. So let's say area of the lawn equals, in terms of L, so this is 40L up here, 40L, and how do we get from 40 to 8? Well, it's minus 32. 40L minus 32 gives you the correct answer. That is the correct answer, guys. And this gets you the excellence grade. A correct expression for the area in terms of L is the excellence. Okay. You've got a merit is up here, and achieved, even just forming an expression for the area of the lawn gets you the achieved. You might be thinking, well, what happens if I use the x equals 10 from the previous question over here, right? You can do that, but it's not correct, basically. This would get you going ahead and using x equals 10 in your sort of area calculations would once again only get you an achieved. So it's a valid idea, but not correct with what we're trying to do here. So this would get you an achieved. But okay, that's us for question 1. Let's move to question 2. So question 2, A1, we've got this equation here. Give this equation for P in terms of Q, R, and W. Okay, so let's first write out our equation. We've got W equals PQ squared plus R. And the question's asking us to give the equation for P in terms of Q, R, and W. So basically we're making P the subject. So P in brackets, or sort of P equals ... Okay. So we're rearranging to make P the subject. The first thing we can do is take R to the left-hand side. We're going to say W equals W minus R equals PQ squared. And then to get P on its own, we can divide by Q squared on both sides. So you've got W minus R over Q squared equals P. And this, guys, is the correct answer. So correct expression for P gets you the achieved. Pretty straightforward. Okay, let's keep going. So question A2, we've got this long equation, fk squared minus 9c squared equals 4d squared plus 16gk squared. And similar to the first question, give the equation for k in terms of c, d, f, and g. So in this case, we're making k the subject. It's going to look like k equals ... So the first thing we do is write out our equation. 9c squared equals 4d squared plus 16gk squared. Okay, and we're wanting to get k on its own. So we know we're probably going to have to factorize because k appears twice in this equation. You've got fk squared and 16gk squared. So let's bring all the k's to one side and see what happens. So fk squared minus 16 gk squared, and at the same time we'll bring the 9c squared to the right hand side, so you've got 4d squared remains unchanged and plus 9c squared. And now once again, I mean, if you're familiar with these questions, you've got a sort of path set out for you, but if you're unsure, just do the first thing that comes to mind. We're going to factorize out k squared here. K squared, and then inside the brackets you've got f minus 16g in brackets, and that equals 4d squared plus 9c squared. And now we can say k squared equals 4d squared plus 9c squared, and we're multiplying on the left hand side. We're going to divide by f minus 16g on the right hand side. So f minus 16g, and of course this is all trying to get k by itself. We're trying to get k as a subject, but we've got k squared here. To get k on its own, we're going to do the opposite of squaring. We're going to square root both sides, so eventually we're going to end up with k equals the square root of basically 4d squared plus 9c squared over f minus 16g. And this, guys, it's actually an excellence question. So, excellence. Expression for t, the marking schedule mentions plus or minus. That's a good point. Plus or minus is not required, but for the sake of giving a complete answer, and in coming years you will be required to do plus or minus, so plus or minus the answer. Okay, so that's the excellence, with or without plus or minus. Your merit is factorizing, so here is your merit, and one valid step leading towards both terms involving k squared on one side gets you the achieved. So our first step up here, so achieved. Okay, a pretty decent excellence question. Let's keep going. So question 2b, you've got simplify as far as possible this expression 3x squared plus 9x over x squared minus 9, okay? So the first thing I'm going to do is just write out a question, 3x squared plus 9x over x squared minus 9. And with these sorts of questions in the MCAT, 90% of the time you're going to be factorizing. So let's say equals, let's look at the top, let's look at the numerator. So you've got 3x as a common factor, and inside the brackets x plus 3, because 3 times 3 is 9. And on the denominator, now this might trip some people up, x squared minus 9. This is a special case for a quadratic. This is, they call difference between squares. You've got x squared is obviously a square number, and so is a 9. And factorizing this, it's actually going to be x plus 3. And to ensure that we get -9 and cancel out the b term, because it's, I mean, you could write this longhand and say x squared plus 0x minus 9. Might make it a bit easier. And so it's x plus 3, x minus 3. And that is the correct factorization. Difference between squares, guys. You might have, for example, x squared minus 64. And this would equal x plus 8, x minus 8. So same with, 49 would be plus 7 minus 7. 100 plus 10 minus 10. Same principle. X plus 8, x minus 8. Okay, so let's take this and put it in our fraction. X plus 3 and x minus 3. And this equals, now we've got, at this point we can look to cancel out or simplify. You've got x plus 3 as a common factor here and here. And so we're going to cancel these out. And we'll be left with 3x over x minus 3. And this, guys, is the correct answer. This gives you your merit grade. Achieved. Once again, the marking schedule mentions x doesn't equal 3 is not required, but once again, in coming years that could well be required, because that would give you a denominator of 0, and okay, we don't want to be dividing by 0. Nevertheless, merit, so you're achieved, just comes from factorizing, so up here. Okay, let's keep going. So, question 2c, we've got write 8x minus 1 over 4 plus 3x minus 5 over 3 as a simplified single fraction. So we're combining these two fractions into a single fraction. Let's first write out the question. 8x minus 1, 8x minus 1 over 4 plus 3x minus 5 over 3. And as always, there's a couple ways to do this. You might, for instance, multiply this left fraction by 3, and actually this is a different way of expressing what we're going to do, but it's actually the same. You might say 3 over 3 and multiply this right fraction by 4, and that is what we're going to be doing, more or less. So we're going to cross multiply. So we're going to go a different color. We're going to multiply this way, we're going to multiply this way, and we're going to multiply our denominators also. So what this looks like is this 3, 8x minus 1 plus, and we'll keep them as single fractions for now. 4 times 3 is 12, plus 4, 3x minus 5. And this is over 12 again. And so, it's your fraction. It's your classic fractions rules. If you've got the same denominator, you can combine them into one fraction. And at the same time, let's expand these brackets. So 3 times 8x is 24x minus 3 plus 4 times 3x is 12x minus 20. And this is all over 12. Okay, let's bring our working up here. You've got combining like terms. Once again, we've done this before. 24x plus 12x, and minus 3 minus 20. So you find yourself with 36x minus 23 over 20. And this, guys, is your final answer. There's no simplifying there. 36x over 12 into 3x, for example. We're not doing that here. This is your final answer. Correct solution gets you the merit. And combining into a achieved correct arrangement for numerator or consistent simplification of the numerator gets you the achieved. So let's just say up here probably gets you the achieved. Okay, let's keep going. So question 2D. What have we got here? Find the value of y so that the area of the right angled triangle has the same value as the area of the rectangle shown below. All lengths are in centimeters. Note area of a triangle equals half base times height. And we might also say area of the rectangle is just base times height, right? Okay. So the key piece of information in this question, when you're trying to set up your equation, is this right here. Has the same value. Area of the right angle triangle has the same value as the area of the rectangle. So we can say area of the right angle triangle equals the area of the rectangle because they're the same, right? And now, what actually are these areas? Area of the triangle is okay. So let's say half base times height for the triangle, and for the rectangle, it is base times height. Let's say b dash h dash. Okay, and so we've got our formula, if you will. All we got to do is plug in the side lengths. So we're going to say, looking at the triangle, it's half 5y plus 9. This is actually the height, but it doesn't matter which way around. 2y minus 2 is the base. And this equals, looking at the... Okay, let's highlight just to make it easier for ourselves. This is the triangle, and now looking at the rectangle, 2y and 3y minus 1. Base is 3y minus 1 and 2y for the height. And now let's expand. We can expand. Let's keep the half as it is for now. And let's expand these brackets. 5y times 2y squared is 10y squared. 10y squared minus 10y plus 18y gives you minus 10y plus 18y gives you positive 8y and minus 18 equals, expanding the right hand side, you've got 6y squared minus 2y. Now we've still got this half to deal with on the left hand side, this right here. What we're going to do is take this, you could apply it to the 10y squared plus 8y minus 18, but it's a little bit complicated, especially if it doesn't work in other scenarios. So we're going to move the half to the other side. Let's keep the left hand side as 10y squared plus 8y minus 18. And if we've got half on the left hand side, we're going to multiply by 2 on the right hand side in order to cancel out. So 2, 6y squared minus 2y. And this is in brackets. So let's keep going. 10y squared plus 8y minus 18 equals 2 times 6y squared is 12y squared minus 4y. Okay, we've got a quadratic sort of materializing here. Let's put it in ax squared plus bx plus c form. So we can say x equals, moving the 10 to the right hand side, it's 2y squared minus 12y positive 18. And even now we can factorize out the 2. You've got 2y squared minus 6 plus 4 plus 9 rather. This is 18, not 8, plus 9 equals to 0. And because it equals to 0, we can just cancel out just like that. How much space are we working with here? Okay, we'll bring it up to the top. So we're left with this quadratic y squared minus 6y plus 9 equals to 0. And actually it's a pretty straightforward quadratic. It's minus 3 minus 3 are our two numbers, so y minus 3, you might write it in binomial form, but just for the sake of our working, let's do 2 sets of brackets, equals 0, and therefore y, we're working with y here, y equals to 3. And this, guys, correct value of y found gives you the excellence grade. Simplifying down to a quadratic or getting a correct solution from a incorrect quadratic gets you the merit. So let's say here, and there's lots of ways you can get it achieved, even just forming the equation for both areas, so achieved as early as this step here. Okay, that's us for question 2. Okay, question 3a. Mary gives some clues so that her secret number can be calculated. She says, when 20 is divided by my secret number, and then 7 is added to this answer, this gives a solution of 2. So we're looking for, the question says, what is Mary's secret number? So let's call the secret number now x, right? It's a variable. We're looking for x. We're trying to solve for x, in essence. So let's just break down the question. And let's look at this first part. When 20 is divided by my secret number, so we can say 20 over x, and then 7 is added to this answer, so 20x plus 7, and it gives a solution of 2, so equals 2. And now we've got our equation here. So 20 over x, let's move 7 to the right hand side, becomes minus 7, equals 2 minus 7 is minus 5. And then we can say 20 over minus 5, rearranging, equals x. and x therefore equals minus 4. And this, guys, correct solution gives you the achieved here. Okay? So question 3b, solve the inequality 6, 5 minus 2x minus 4, 5 minus 3x is greater than 5x minus 4. Okay. So it's just about being methodical here. It's a pretty straightforward inequality. Let's first write out the question. Apologies. 5 minus 2x minus 4, 5 minus 3x is greater than 5x plus 4. And all we're going to do is expand the brackets, put x on one side, and then solve for x. So this first bracket, we've got 30 minus 12x minus 4 times 5 is minus 20. Then minus 4 times minus 3x is positive 12x. And this is greater than 5x plus 20. So collecting like terms, once again we can highlight to make it easier for ourselves. You've got the x's here and even here, and just the single digits, 30 minus 20 and positive 20. So looking at the x's first of all, these actually cancel out. Looking at them, minus 12 plus 12 cancels out. 30 minus 20 is 10. It's greater than 5x plus 20. We can move the 20 to the left hand side, it becomes minus 20, so you've got minus 10 now is greater than 5x, and dividing by 5 on both sides, you've got x is less than minus 2, and you could even write it like this: x is less than minus 2. And this, guys, gives you correct solution, gives you the merit. Oh, apologies, this is merit here. Expansion of brackets, just anywhere on the line, along the line here. Even if it's not correct, you might get an achieve. So given as you've got a solution given as an inequality. Actually, not an inequality, but rather just an equality. So if you said maybe x equals to -2, you would limit yourself to an achieved. But let's say expansion of brackets gets you the achieved, so here. Okay, let's keep going. So question 3c, we've got solve the equation x plus 12 over x plus 4 equals x plus 4 over x plus 2. So you've got two fractions that equal each other. This is maths that you should have come across before, hopefully. And immediately you say to yourself, okay, we're going to cross multiply. And what I mean is this. We use a different color. We're going to multiply x plus 12 and x plus 2. And we're going to multiply x plus 4 and x minus 4. There's no multiplying of denominators here. So we can express this as x plus 12, x plus 2, equals x plus 4. You could say x plus 4 squared, all squared. Just going to go the long route here, x plus 4, x plus 4. And now expanding these brackets, you've got x squared, 2x plus 12x's plus 14x. And then 12 times 2 is 24. And this equals x squared. The b term is 2ab, which is 8x. And then plus 16. Okay, now we've got to simplify. Collect like terms rather. X squareds cancel out. And we're left with, let's bring the x's to one side. 14 minus 8x is 6x. Equals, we'll take the 24 to the right hand side. 16 minus 24 gives you minus 8. And now dividing by 6 on both sides to get x by itself. X equals minus 8 over 6. Or you could say x equals minus 4 over 3. Just simplifying further. Either solution, guys, will give you the merit here. Expand the brackets gets you the achieved. Okay, pretty straightforward. Let's move on to question 3D. So question 3D. The diagram below shows a sketch of part of the graph, and we've got this equation here, y equals 7 plus x. What is this? 7 plus x. Let me highlight, there we go. Minus 6x squared. Aroha draws another line onto this graph with the equation y equals x plus 4. And it's shown this diagram here. This is the 8x plus 4. And even we could use a different color. This is 7 plus x minus 6x squared. And actually now looking at, let's take out that highlight just to make it easy on ourselves. The question says, find the x values of the 2 points where the two graphs intersect each other. Okay. The crux of this question is the fact that the two graphs intersect each other. And when they intersect each other, it means they touch, right? And it's here and here. At this point, we can say y equals y in terms of coordinates, and actually in terms of the equations themselves. So if y equals y, we could say 8x plus 4 equals 7 plus x minus 6x squared. So the equations equal each other because they're touching, right? The same coordinates at a particular point. So now we can put all our terms on one side, get ourselves a quadratic, and solve that quadratic to find the x values. So now let's bring the negative 6x squared to the left hand side just to make it positive. 6x squared, and then 8x minus x is plus 7x. 4 minus 7 is minus 3. And this equals to 0. And now we're solving this quadratic. Once again, there's a few different ways you can do this. Let's say 6 times minus 3 equals minus 18. And so we're looking for two numbers that multiply to minus 18 and add to the middle term, which is 7. And this is positive 9 and minus 3. So we can say 6x squared minus 3x plus 9x. We're splitting this middle term now, this b term, minus 9x minus 3 equals to 0. We draw our line down the middle, factorise the left-hand side, 3x, and then 2x minus 1 is the bracket. And then the right-hand side, it is, I believe, positive 3. Yeah, positive 3. 3. Here we go. This is our mistake. It is not 9 and 3, but rather 9 and 2 are our two terms. So it's positive 9 and minus 2. So our factorization is 2x, 3x minus 1. Okay. And then you've got plus 3, and then 3x minus 1. And this is what caught my attention, because you know you're on the right track if the two brackets are equal, and that wasn't going to be the case beforehand. So now we can say 2x plus 3, and then 3x minus 1. These are our two brackets, equals 0. And then all we do is solve for x. So 2x plus 3 equals 0. And x therefore equals minus 3 over 2. And 3x minus 1 equals to 0. So x equals to 1 over 3. And this, guys, gets you the excellence grade. Correct solutions gets you the excellence grade. Getting the quadratic down to factorized form gets you the merit. So up here, and even just forming the single quadratic equals to 0 gets you the achieved. So up here. Okay, let's keep going. So last question, guys. Question 3e. The equation of the straight line passing through the points 5, minus 10, and 9, 11 is given by this equation qy equals px plus 5. Okay. So the key thing, and this is the case with, basically every excellence question, there's a sort of hidden piece of information that you've got to extract. A coordinate is written in the form x comma y, right? Meaning we could say, when we look at our equation, qy equals px plus 5, how are we going to find the values of the numbers p and q with 4 unknowns, right? 4 variables? We have to eliminate 2 of them. And we can eliminate x and y by saying, looking at our quadratics here, minus 5 represents the x term in the quadratic, minus 10 represents the y term. Same with 9, 11, you've got x and y. Okay, so let's take this first quadratic, and we can substitute in x and y. We can eliminate these 2 variables, and this will help us to find the values of the numbers p and q. So, minus y minus 10, working with this quadratic, you've got, once again, x and y. So we could say q minus 10 equals p minus 5 plus 5. And just simplifying this, sort of clearing it all up, you've got minus 10q equals minus 5p plus 5. Okay, that's our first equation. And now, with the coordinate 9, 11, again, this is x, 9 is our x, 11 is our y. We can say Q11 equals 9, okay, P 9 plus 5. And again, just rewriting this in the more conventional way, you've got 11Q equals 9P plus 5. And now we've got two equations, and remember we're trying to find P and Q. And so we haven't got a simultaneous equation yet in this 2019 paper, but now we do. So how are we going to solve this? It would be difficult to use the substitution method because neither P and Q in either solution are sort of on their own, right? So we can't rearrange to make them the subject. Let's use the elimination method. So first of all, we have to make either P or Q the same for both equations. So let's look at Q, and let's multiply this equation. Let's use a different color. We can use red. We'll multiply this equation by 11 and this equation by 10, and I believe it doesn't matter if you use positive or negative. Let's just use positive in this case. So multiplying by 11, you've got negative 110q equals minus 55 at p plus 55. And then for the second equation, we've got 110q equals 90p plus 50. And now hopefully you're familiar with the elimination method. We can look at the 110 and we can say we're going to add the equations. And so these cancel out. We're left with 0 equals minus 55 plus 90. We can even highlight this to help ourselves. We're adding these, and we're adding these. Minus 55 plus 90, what does that equal? Minus 55 plus 90 equals 35. 35p. 55 plus 50 gives you 105. And now solving for p, we can say 35p equals negative 105. We've taken 105 to the left-hand side, and we've just flipped the equation. P equals minus 105 over 35. You'll find that equals 3. Negative 3 in this case. So we've got P. Now we have to find Q. So we take any of our equations, and then we can solve for Q. let's go back to our sort of smaller equations before we multiply by 10 and 11. And let's grab this equation. And we'll say, we'll rewrite it. 11q equals 9p plus 5. Substituting in p, you've got 11q equals 9 times negative 3 is minus 27 plus 5. So 11q equals minus 22. And q equals minus 2. And these two solutions, guys, this and this, gets you the excellence grade. Your merit is finding one of the solutions. Yep, so correctly finds the value of either P or Q. So let's say here, merit, and forms both equations, consistent combining of their equations in one variable. Okay, so somewhere around here.
Yeah. Okay, guys, thank you all for watching. If you have any questions or suggestions, feel free to put them in the comments below, and I'll see you next time. Cheers.